So we're still talking about 6 transformations. We've already talked about 2, and that was vertical and horizontal shifting. And now we're moving to compressions and stretches. So these are 2 new tools for your toolbox. Okay, so let me tell you what each of these things are. Stretches. When the right-hand side of y equals f of x is multiplied by a number c greater than 1, then the graph of the new function is a vertical stretch of the original y equals f of x. Okay? What does that mean? Well, let's say that I have the absolute value of x drawn. So this is y equals the absolute value of x. If I were to take that and say multiply that by a number greater than 1, say 2, then what that will do to the graph is I claim it's a vertical stretch. So what does that mean? Basically this blue graph will look something like this now. There'll be a new graph and it will look like that, and that corresponds to what I wrote there. Notice that the blue over here has been stretched up, and it also has been stretched up. And it's stretched up, it turns out, by a factor of 2. Okay, let's go to the other idea, concept number 2 of this lesson, compressions. So now when you take a function and you multiply it by a number where this time the number is a fraction, that means it's between 0 and 1, that's a fraction, then the graph of the new function y equals c times f of x is a compression of the original. So now what I want you to think of is, again, I have this, say, as an example, the absolute value of x. So now what I'm going to do is I'm going to say multiply it by 1/2. So this new graph will be a compression. That means it was this, and now it's going to go down in y. It's going to open up. So it's like the fraction makes it look fat. Fractions make it look fat when you multiply in front. Okay, let's go to example number 1. So example number 1 says this. You're given a function, y equals 2 times x squared, and you're asked to graph it. Now before we begin, you'll notice that the x squared is being multiplied by 2, and I told you that whenever you multiply by a number larger than 1, it's a vertical stretch. So we expect that when we do this, that our graph is going to look skinnier and stretched up more so than y equals x squared. If you don't see why, you could actually do the following. You could make a table of values. For example, when in the original x was 1, then y is 1, because 1 squared is 1. But now when we try y equals 2 times x squared, when you do that, when x is 1, y is 2. So let's see that. So right away you see that that y value is stretched by a factor of 2. Let's try x being 2. When you do that, you get 8. So when x is 2, y goes all the way to 8. When originally, when the other function, x was 2, y was 4. Okay, so when x was 2, y was 4. So you'll notice that the graph is shifted up by a factor of 2. So I'm going to draw this new graph. Okay, sorry about that, but it's basically a parabola that's stretched up. Wow, that's horrible, but I think you see the point. It's just inside, it's stretched up. Okay, so that's the answer to that one. It's the blue graph. Now let's talk about the next one. Graph the function, I need to insert it, y equals 1/2 x squared. Okay, so now we're multiplying by a fraction, and so I said that fractions make it compress, they make it look fatter. And so we can see that, and when we do that, let's try, for example, making a table of values, x and y. So when x is 1, y is now 1/2. When x is 2, y is 2. So let's do that. So when x is 1, y is 1/2. When x is 2, y is 2. And so I'm going to draw this. Okay? So you can see now that the purple y equals x squared, the original, has been compressed by a factor of 1/2. And it's going to look like symmetrical on the other side. Okay? And then it would continue. So that's the answer to example 2. It's the blue graph. Okay, example 3. This is very similar to your homework. It says this. This is a multiple choice question. Graph the function using the techniques of shifting, compressing, stretching and or reflecting. We haven't done reflecting yet. Start with the graph of the basic function shown below. So remember, it says 6 times the square root of x. So I want you to remember that when you have a number larger than 1, what it does is it makes it stretched up, okay? So we basically just need to pick off the answer choice where this is going to go up a bit. And the only answer choice that there is this one, choice A, okay? The others don't work, okay? Now we're on to number 4. This is the last page of our lesson. Write down the cubing function, vertically compressed by a factor of 0.7. So the cubing function is y equals x cubed, and if I'm going to vertically compress it, it just means you have to know that you're just multiplying it by 0.7. That's all there is to that example. Okay, now we're on the last example. Suppose that the point 2,4 is on the graph y equals f of x. Find a point on the graph of y equals 2 times f of x. Okay, so what it's going to mean is this. When you plug in 2 into that, well, you already know that it's 4. So you're going to get out 2 times 4, or 8. So the answer is 2, 8. Another way you could have done it is you just recognize quickly that 2 in front means you're vertically stretching it by a factor of 2. So the old y values go up by a factor of 2. So 4 went to 8. And that's all there is to this.